Okay, everybody, sorry about that. Munching on a banana, getting some potassium in me. Okay, so give me a like to see if you guys can hear me. Let's get started on that. Let's get the likes going. All right, we got the likes coming on in. And so, ladies and gentlemen, let's review about some ideas that are coming that we're going to be talking about. Let's go to the browser here. And in the browser, let's go to Math 241. 241 right here. I'm going to remind you guys, you have test 4 here. And this is your test 4. These are some questions you guys want to work with. Some people already turned it in already. Fantastic if you have. This is some good review of some things that we'll have to be able to do. And, you know, I'll create a study guide for your final. And this is due the day of your final. So it's on my website. It's also in Canvas. I sent that to you guys. So you have Tuesday, December 15th. This is when that test is due. It's actually next week. So at 9:30 a.m. So ladies and gentlemen, that's the due date. By this weekend, I'll get you a nice short study guide. And if you're working on these test 4 items, of course, some of that stuff definitely will be there. But we're reaching the end of this, okay? So anyway, we have to talk about a few things. And, oh, yeah, let's check our internet speed. Let's see if we're good to go, right? We want to document that, see how you guys are doing with that internet, at least on my end. So on my end, I'm checking my internet speed to show all of you. And it's about, you know, let's see where we're at. Anything for me, excellent for me is above 90 or 900, which is 90% of a gig. So we are an excellent download speed. Let's see the upload speed. I hope that keeps up because that would be very, very good upload speed. So yeah, it did. So we have very, very good upload speed. So set YouTube to HD to maximize your experience. As you guys know, we do this every day. And we're now good to go here. So I'm going to get out, don't know what that is, but I'm going to get out this iPad here for you guys. And we're going to do something here. Let's maybe get you, I don't know, I might have another already listed there. Let's see what happens. And we're going to title this Graphing Polar Curves. So we might even have one already. Anyway. So here's kind of, oh, we already have one. Okay, so I'm going to change this if I can. This is kind of strange. It doesn't allow me. I try to get in front. And it doesn't let me do that. I don't know why. So I'm going to have to say fall 2020. Graphing. Okay. Now it'll work. But I do want to go back to the browser briefly now that I remember something here. Okay. So if we go to worksheets and videos, here's what I did for you guys yesterday. I actually have a video on, you know, the polar coordinates. And it's about an hour length. This was done 3 years ago. So, you know, plotting in polar form, I did a video for you guys, you know, a long time ago. And let's make sure if this is set to HD. Yeah, it is. Anyway, if you click on that link, it'll take you to that video. I also have polar equation conversion. So I did that 3 years ago as well. So I went over some examples about how to convert to polar, just like I worked on yesterday. So if you want to see more examples, it's there. So you do have additional examples. And then I also have the last one, graphing polar curves, which is something that we're going to work on now as well. And there's about an hour and 42 minutes of examples. So I'm going to have to go over the procedure for how to graph polar. And, you know, so you have extra examples there. And so I think that's wonderful for you. So I did want to communicate this for you guys. So if you did have some time to go take a look at some of these, if you had any questions or issues, and they're the last 3 there. That was all done 3 years ago. So my students have been looking at this for 3 years. All right. So I just want to let you guys know, yes, you have some good resources for yourself. I don't mind if you put a like by them, but, you know, I guess people these days, you know, they don't put likes behind math videos. I'm not sure why. At least not mine. That's odd. I don't know. Maybe I have to advertise better. I have no idea. So they're going to want you to graph polar curves. And let's get started on some of these. I'm going to first start with, you know, the lines and then the circles, and then I'll proceed from there. And then after that, I think I'm going to do the cardioids for you. And we'll talk about some of those, and then we'll see what else comes up. So we can at least get started. And I want you to know that they're going to give you R is a function of theta. And R and theta is how we plot points. So as you've seen from yesterday, if they said to graph simply, theta is a constant, that's going to be a line through the origin. It's not every line, but lines to origins. And if they say pi over maybe 3, you know, this is a polar curve. Okay, theta is pi over 3. Now, there's a couple of ways we can do that. You know, personally, if you took this course in like a Calculus 3 course, I'm trying to remember, for me, it's a kind of a simple thing. I know for us, we're learning this, and I already know what this is going to kind of be. So I guess let me go back here. I'm going to do that there. I'm going to cut that. I'm going to get our polar. Yeah, let's get the polar axis here. So let's get the polar axis. I think that's way down here, because it was like done over 3 years ago, maybe even longer. Yeah, there we go. Let's bring that in, okay? As you guys know, we're trying to graph this. We have our pole right in the center. We have our polar axis, and it's aligned with the positive x-axis, but we don't have to draw that. Now, what I want to remark here is this. When they give you theta as a constant, R is variable. So from first principles, I think of this as any R, and then the angle is, pi over 3. So I know pi over 3 is 180 divided by 3. That's a 60-degree angle, so you guys know. And since R can be anything, R is arbitrary. You can say R is a variable, but R is arbitrary. That means the same thing. It could be any value. So we got this pi over 6 and any R value. Here's what I mean. If R is 1, here's where pi over 6 is, right? Let me do this. If I can find it. There we go. R, ladies and gentlemen, my angle here is 60 degrees. R can be any value on that line, because it's arbitrary. R can even be 0. R could be negative. So these are all points that are along a line. And so if you ever said to me, you know, Mr. Judge, how do you graph this? I'll just say, go through the origin. Here's one way. And here's the graph of simply any constant value. That's the polar graph. And it's the line, you know, you can convert this, and you can say, yesterday you showed me how to write this in terms of rectangular coordinate system. You took the tangent of theta, tangent on both sides, right? And then you say, oh, you're going to let tangent be y over x, and that's tangent of pi over 3. And so y will be, you know, tangent pi over 3x, whatever value that is. And you say, well, that's a line in rectangular coordinates. And it is, and this is the same line. So, you know, I can look at this from first principles and say, whenever I see theta is a constant, and you see these a lot in a calculus course, or even in a trig course right now, you can have theta as a constant. I would just say, just graph that angle through the origin. and it must go through the origin. The rectangular coordinate version, we seen yesterday how to do it. So pick your poison, and I'm saying to you, our poison today is to stick with the polar coordinate system and graph in polar coordinates. So even if, for example, they said, what is theta? Theta is minus pi over 2. And they want us to, graph this, and I'll keep pulling this in or copying. We can draw a line there. But you now say to me, well, how do we draw this line? And I think this doesn't like it. Yeah, it doesn't like when you are on that imaginary line. Anyway, let's bring this over here. So you got theta is a constant again. So negative pi over 2, that's when I take this polar axis and rotate it, in clockwise. And here's what you can end up with. And so you might say, do we describe this as also r is arbitrary, but the angle is fixed, it's constant? And I'll say yes. And so that means your line really is this line to the origin. I can kind of draw it that way. I know it's a little crooked, I apologize. So that's the line now, and that's the polar version. So when your angle is constant, we know it's a line through the origin. And that, like I said, is very much what you see. And you can see, others, right? They can say, how about theta being negative pi over 4? And let's see if I can copy this. I might be able to. Okay. Not without copying everything else, but okay. So now you might say, since this angle is negative pi over 4, that's negative 45 degrees. So we're going to be over here now. You're going to rotate negative pi over 4. So r could be any radius value. Oops, something's going on here. There we go. Here's our line L. So again, in this case, r is any value. R, and the angle is minus pi over 4. And there it is. There's the line in the world of polar coordinates, and it'll always be through the origin if you have theta is a constant here. So does anybody have any questions on how to graph these angles where theta is constant? Because I think that's an important thing to know in your future. Just theta is a constant as a line through the origin. Any radius value. You say all these points, whether they're positive or negative, but yet you're consistent with the angle, the answer is yes. Okay, so this is where theta is a constant. Now, compare that to r is a constant. Like maybe r is 3. And you might say when r is a constant, what does that mean? It means you have a circle. But the center is at the origin, and the radius is actually 3. Now you might say, how do I know that? Well, notice if I square both sides like we did yesterday, we'll get r squared is 9, and r squared is represented by x squared plus y squared. And this is what I'm saying, that x squared plus y squared is 9. That's the equation of a circle centered at the origin, and the radius is 3. So I want to remind you guys, this is what we have yesterday. So if we ever have r as a constant, it is always a circle centered at the origin with that radius value. And then you say, well, what does that mean? Let's see if we can, if it remembers. Can we paste? Oh, no, it doesn't remember. So, copy, paste, move that down. All we have to do is draw a circle of radius 3 in this polar axis. So we have to know, how do you do that? Go to the right 1, 2, 3 units. to the left. 1, 2, 3 units. Up. 1, 2, 3 units. Down. 1, 2, 3 units. Okay. So I can try to draw a circle. And there we go. I think that's close enough. But this is the graph in polar form. You just graphed what we call r equals 3. It's a circle centered at the origin with radius 3. So, you have to draw lines. You have to draw circles in the polar world. Okay, because just by essence of what you're looking at this, you have a bunch of lines and circles by just the picture, right? You got lines and circles there. And ironically, I should say, let's note that just because in the polar form, the radius values can be negative here, right? So this graph r is negative 3. If we square both sides again, right? You say, I'm going to square this, and you have to put parentheses and square. You got this here. You got r squared is 9, and r squared is x squared plus y squared. And that's going to be your circle centered at the origin. This is equal to 9. So origin, radius is 3. You might say, oh, here's the origin, Mr. Judge. You already did the radius is 3, right? Those 3 dashed lines. And I'll say, yeah. It's the same exact circle, by the way. So if your radius is positive or your radius is negative, in polar form, that is allowed. Okay, so you got the same kind of idea here in polar form. X squared plus y squared is 9. It's the equation of the circle centered at the origin. So, you could do this all day long. You have the unit circle. If they give you, for example, r is negative 1 or r is positive 1, you might say, Mr. Judge, if I already know that it's a circle centered at the origin, my radius is 1, can I go straight to graphing it that way? And I'll say, absolutely, sure can. Just make sure you draw a circle now, centered at the origin, whose radius is 1. And you might say, how does that look? Well, it looks like this. If I can get, there we go. So radius is 1. There it is. So every time radius is a constant, it's just a circle centered at the origin with that value. And that's how we start to sketch. Now, anybody have any questions on these here? This is kind of a very good start, drawing lines and circles. Because we have now, I'm going to step up to probably, excuse me.
I'm not sure I understand.
Sorry, my banana is on top of my keyboard. You guys have no idea how I'm working out here. Let's give you some more circles. Or how about this? Here's what I think is important to do. Cardioids. I'm going to start with this. Cardioids. With a heart. When you think of cardioid, think of a heart. And cardioids have different forms. R equals, let's put this down here. A plus or minus a sine theta, or a plus or minus a cosine theta. This is the family of cardioids, by the way. Now, they'll either open up normally like a heart. You say, okay, they'll open up this way, or they'll be in reverse or upside down. And there you go. Or they'll open to the right, or they'll open to the left. Sorry, you'll never guess that both my parents are artists, right? I know I say that all the time. So, for example, if they want you to graph a cardioid, this is how we want to do this. They're going to say 2 plus 2 may be sine theta. Now, I'm just making this up. We can start with 1. Okay, this is a cardioid. So we're going to start to draw hearts, and it's fun. So let's draw some hearts today. But here's how you do it. Here's what you're going to do, ladies and gentlemen. Here's the key. You're going to let y be the r value. You say, what do you mean? Here's what I want you guys to consider. What's the graph of y equals 1 plus sine theta in the Cartesian coordinate world? So we have to graph sine theta plus 1 in Cartesian coordinates. And so I'm going to start to do that. So notice something here that, you know, when students say, Mr. Judge, is this final comprehensive? I'll say, yeah. And notice if they want you to graph in polar, r is 1 plus sine theta. And they do. You go to the graph of y is 1 plus sine theta in the Cartesian coordinate world. This is how we go about it. Here's y and here's theta. Now, sine theta, remember, we have pi over 2, 3 pi over 2. We have to know how to graph those. So you might say, oh, I thought I was done with that. I never had to see that ever again. And I'll say, no, you see everything over and over. So remember how you graph sine, ladies and gentlemen. And I'm going to do this. I'm going to put a dotted version of sine. And I'm going to only graph one cycle, by the way, 0 to 2 pi, right? And this is the sine curve, but they want us to graph y as 1 plus sine. So if you remember, that just shifts everything up 1. So everything gets shifted up 1 unit, okay? So the origin goes up 1. This point goes up 1. This point goes up 1. And this point goes up 1. And in fact, the axis here goes up 1. So I'm going to put the dotted axis now. Now, if we shift this up 1, your curve really looks like this, ladies and gentlemen. Oops, we forgot to do the last one. Okay. We forgot to shift the last one up 1. So in red, we have y is 1 plus sine theta. So I'm going to graph one of the simplest cardioids you can see in your life, okay? And the key is let the r value be y and go to the Cartesian graph. All right, that's your first step. So this is where we start to graph our cardioids. So take a look. So if you said, boy, Mr. Judge, are you going to ask me to graph a cardioid on this final? Probably. Or are you going to ask me to graph y equals 1 plus sine theta? I don't know. I may not have to if I ask you to graph y as 1 plus sine theta. And of course, you show your work. You don't go to a TI calculator and just sketch that. If you do that, you're not getting any credit. You got to show work for credit, ladies and gentlemen. You know, so those people that had those plans are out the window. So I'm going to get rid of the ghost curve. I call that a ghost curve. Boy, I thought I was going to outsmart Mr. Judge on my test. All right, now, this is what you guys do. Here's what's important, okay? You need to know these addresses, the addresses on your curve. Okay, now I know it's y, but think of it as r theta, right? This is really r. What are those addresses? R theta. So this is the address. So I want you guys to look at this point here. This point is going to be, when my angle is 0, this is 1, 0. This is in r theta. And then now this will be 2 comma pi over 2. So I want you to focus on those 2 points right now, right? Here and here. R is 2. The angle is 90 degrees. And then R is 1. The angle is 0. And I want you to call this portion 1. So let me focus on this here. This is in orange. I'm going to go through this in very much a lot of detail. So that curve goes from 1, 0 to 2 pi over 2 in portion 1. And I'm going to say, what is this point here? I'm just going to label this point here. Well, this is R is 1, angles pi, right out here. And I'm going to label this portion 2. I'm going to change the color to green. So this is how we start to graph cardioids. This is just the start. And then I'm going to label the last point here, or the next point here. We got, oh, my radius is 0. The angle is 3 pi over 2. So I'm going to say here we're at 0, 3 pi over 2, this location. And I'm going to use the color purple. And this is labeled region 3 here. Finally, the end over here, R is 1 and 2 pi. And we're going to change this color. It's gold. I'm going to name this region 4. So we got 4 regions here. And this is how you go about this, ladies and gentlemen. So notate all these points while I bring, you look at your own notes, hopefully, while I bring in a polar graph, because you guys are going to see how this works in great detail. We're going to see how this works, ladies and gentlemen. We're going to have to accommodate all those colors and point. Start with the first one. You're working left to right. 1, 0. You have to know how to graph in polar. Radius is 1. Here's what I'm saying down here. You have to know, how do you plot 1, 0? That means the radius is 1 and the angle is 0. Here is that point. I'm sorry, it's so small. Right? It's not to scale. So that's the first point, ladies and gentlemen. It's going to be small today. I might be able to increase the size, but okay. And then you say, well, what's the next point? Let me point out to you the next point. The next point is the radius is 2 and the angle is 90 degrees. So you might say, okay, I went from 1, 0, you did, to 2 pi over 2. So that's up here. Remember, this is 2 units. And I don't think it's the scale, but I apologize. I think I made a mistake. But here's my point to you. 1, 0, 2 pi over 2. These are the coordinates. And so notice in orange here, we went from 1, 0 to 2 pi over 2 in orange. So I'm going to sketch a curve going from 1, 0 to 2 pi over 2. Oops, let me do a little bit better. I don't know how much better that is, but here's kind of what I'm talking about. So we're going from 1, 0 to 2 pi over 2. Notice the radius went from 1 to 2 just in 90 degrees. And that's the first part. That's only the orange part. Okay, anybody have any questions on that first part? We now have to go to the next point, and the next point is at 1 pi. So 1 pi, ladies and gentlemen, is out here. This is the address of 1 comma pi. And notice what happened. You went from 2 pi over 2 to 1 pi in green. So I went from here to here, ladies and gentlemen. So there you go. That's the green portion. That's portion number 2 in green. So we're reading this curve here. And then you say, I go back to 0, 3 pi over 2. Well, where is that? Well, 3 pi over 2 is 270, and the radius is 0. So I'm going to go end up back at the pole. Is that right? How could that be? You go from 1 pi back to the pole in purple. So I'm going to start over here in purple. And how do I get back to the pole? That's how it looks like I'm getting back to that pole, because this is 0, 3 pi over 2. And that's the portion in purple. right here. So we went back to the pole. And the next point, you say, well, from the pole now, we go to 1, 2 pi. Radius is 1, angle's 2 pi. So you say, well, where's that point at? That's over here. This is radius 1, angle 2 pi. So the last portion in gold, we go from the pole back to that starting point. And what you guys see here, ladies and gentlemen, is what is known as a cardioid. So you have to start by graphing the Cartesian one cycle. And all of these here, these curved portions, this is region 1, 2, 3, and 4. This is an inverted heart. It's a cardioid. So you may say, okay, Mr. Judge, let's do this here, right? I don't know what class this was. It might have been ours. You said R equals 1. Notice R is 1 is just a circle plus sine theta. And sure enough, ladies and gentlemen, what do you see here? You see a cardioid. You see a heart. And it's an inverted heart. And similarly, I would say to you, well, what if you had R is, how we started to write this? R would be equal to 2 plus 2. We wanted the functions, sine theta. You would see, essentially a bigger heart. So notice the difference. What I started to write down is 2 plus 2 sine theta, and R is 1 plus 1 sine theta, and you have these hearts here. Okay, now let me show you something here. I'm going to say, we're going to try this. Maybe R, where is this? R, I'm going to try R is 2 plus 2 cosine theta. Okay, and in green, what you'll see is a heart on its side. 2 plus 2 cosine theta. And let me do something like this. R equals 2 minus 2 maybe cosine theta. Maybe we should see how to do that one. So we have cosine and then theta. So there you go. It's on the side. R is 2 minus 2 cosine theta. So ladies and gentlemen, here you go. Let's try something like this. You guys can see how this works now, right? So you already know what that looks like. We're going to do the same sort of thing. So they're going to ask us to graph this cardioid. R is 2 minus 2 cosine theta, right? Remember what the key was. You want Y to be, replace that letter. 2 minus 2 cosine of theta. And then what this really becomes is when you graph this, this is the Cartesian version you want to graph with the same procedure. Yes, it's really R. I mean, and in some ways, if you wanted, I've seen some books will say, just let this be R. Some books write it that way, but look at this not as the polar version. Look at this as the Cartesian version, we're theta, and you now have r here, okay? Or y, but I introduced it to you as y. So if you know how to graph this here, minus 2 cosine theta plus 2, which was the idea you had in the past, ladies and gentlemen, this doesn't go away. This is all based on cosine theta, but you now have the amplitude of 2 and it's inverted. Remember that stuff? So we have the amplitude is the absolute value of negative 2, which is positive 2. This is a negative, so it's reflected, right, about the theta axis or x-axis, horizontal axis, and then this is shifted up 2. So, ladies and gentlemen, this is how we start to graph here. R equals 2 minus 2 cosine theta. And I'm going to move this all if I can, if it lets me, because we need the space, ladies and gentlemen. So let's kind of do that here. So we got to graph cosine with the amplitude of 2. So, I mean, I might try to do that here. Let me do that here. Let's let this be 2 units, okay? Remember, that's the amplitude. We have to get these points correctly in these regions. So cosine starts at top, goes down here. Oops, sorry. Okay, let me switch my angle. Here's the points where cosine goes through, right? We're going to sketch the cosine curve. And then you say, but that's reflected. I know, so this is really, let's change the color then. Let's see, no, maybe red. It's reflected about the theta axis. And then you shift this up how many units? 2 units. So this point is now over here. And maybe we should change colors. Let's put it in purple. So instead of being at negative 2, you go up 2 units. So I'm going to go to all these important points. Up 1. Well, it's wrong one. This point goes up 2 units down here in red. At the axis, you go up 2 units. This largest point value goes up 2. Right? And then this value down here goes up 2. And then here we go up 2 units. So let me double check. I apologize. Let's go back again and start over. I really need to emphasize this. Okay, we have to shift everything up 2. Now you say, what's everything? This point here, this point, this point, this point, and this point. They all go up 2 units. So in purple, I went up 2. I went up 2. I went up 2. We're up 2. We're up 2. Now this should be the cosine curve. The axis goes up 2 units. That's kind of how I do this. And then you might say, well, what does this R axis really go up to? Or R goes up to? If I can draw that, no, that's not good. This here's 4. So I would say to you, remember how to sketch. You know, so if you said, do I have to remember how to draw a curve, a cosine? I'll say absolutely, because at this point you're using it. And the idea, ladies and gentlemen, is that you're good to go with all of these. All right, so yeah, the final is comprehensive because we make use of all of these points, information. So let's highlight these in purple here. Okay, so we have to start with the graph always. So I would say, ladies and gentlemen, definitely start with your graph. Now, notate the addresses, meaning this is 0, 0, by the way, right? And this will be radius is 2. Is that 2 pi over 2? Looks like. Here, this will be radius is 4, angles pi, and then this will be 2 comma 3 pi over 2, and then this will be the radius is 0 and the angle's 2 pi. So ladies and gentlemen, we have all these important starting points here where, again, region 1, region 2, region 3, and then region 4. We got 4 regions, and you can color them orange, green, purple, red, maybe. So you can focus on that. You can see that orange, green, purple, red. Whew. Beautiful. This is how you start, ladies and gentlemen. This is what my favorite part of the course is, because we get to use everything we studied. You know, and so you always start by working with the points and seeing how this goes through. Let's see if I can just paste a Cartesian. It has the old one. I want to make it bigger. So maybe we're a little bit, and it's not going to like that. So I'm going to do this. I'm going to undo that. I guess I can't. I'm going to put it here because it doesn't like, I should say, well, whatever. It doesn't like being pasted pictures on lines. So we're going to do it something like that. Okay. Okay. All right, let's try this out here. Now, the first point here is the origin. It's the pole, the 0, 0. We're going to plot the pole. There we are. And the next point we plot is 2 pi over 2. Okay, so here's my radius here of 2, and the angle is pi over 2. So I have to plot. I have to know how to plot. 2 pi over 2 we put up here. Okay, the angle is 90 degrees and the radius is 2, so there's my location. But I went from in orange, region 1, I went from the origin to 2 pi over 2. So in orange, we draw a arc that looks like this. Because I went from, in that quadrant, 0 to pi over 2, I went from a radius of 0 to, to a radius of 0 to a radius of 2. In that first quadrant. Remember what Desmos says. Desmos agrees. Okay. Now you might say, okay, Mr. Judge, what happened? Where's the next point? Well, from that point, I went to 4 in, this what was it? Quadrant 3, I think. So I went from a radius of 2 now, right? The angle's pi, so it's, I guess it's 1, 2, 3, 4, something like that. And let me do this. It's in red. I think it should be 1, 2, 3. It's not to scale, but whatever. And that color was green. So from this portion, somehow, my radius increases from 2 to 4. And it looks like that. This is just a sketch, ladies and gentlemen. So here's 4 comma pi. There you go. And then you say, what about this next portion here? Radius is 2. Angle's 3 pi over 2. So that's 270. So that next point would be back at 2 here, where you have 3 pi over 2, 270 degrees. So we're looking at this point here. This is why we care about that. So in purple now, we need that purple. So this will go from a 4 radius down to a 2 radius. What just happened? You want to go from 4 to 2. Now again, you'd never guess my parents are artists, but this is just a sketch. And then you say, what's the last portion here? Oh, we did the purple. Now we have to go to the next point, which is 0 to pi. And I need a highlighter. So you say, how do I get to 0 to pi now? Well, where is 0 to pi? You have to graph. 0 to pi is back at the pole. So in red, somehow we get back at the pole in red. We get back to 0 to pi. Remember, radius is 0. Angle could be any angle. It's still the pole. So what you are seeing here, ladies and gentlemen, is a very nice cardioid, by the way. And it's on its side, and Desmos, of course, draws a very nice picture, much nicer than I can draw, but it also puts it on the Cartesian coordinate system, you know. But, you know, this is how we graph cardioids. So notice what you're looking at here. Here's my important point to you. This is a cardioid, and it's represented by the equation here, r equals 2 minus 2 cosine theta. So appreciate what polar is. It's a system that makes our life easier. Because if I said to you, okay, look at what Desmos does. Desmos puts your cardioid on the Cartesian coordinate system. You know, Desmos doesn't change. If this were me, I would have changed the system to polar. But I understand what they're doing. You see, because the truth is, yeah, you are having the polar system superimposed on the XY coordinate system because we're used to working with that. And you can do a lot of math with this XY system because that's the standard system that we're in. But if you said, what equation was that? Notice, you know, if you multiply both sides by r, you get r squared is 2r minus 2r cosine theta. And r squared is x squared plus y squared. 2r minus r cosine theta is 2x. So we worked on this yesterday. X squared plus y squared plus 2x would be 2r. And what they do is they square both sides again. X squared plus y squared plus 2x squared would be 4r squared. And then they replace r squared with, you guys know, we did this stuff yesterday. And that'll be x squared plus y squared, ladies and gentlemen. So if I put in Desmos so that you guys know this equation, I should get the same exact curve, okay? So x squared plus y squared plus 2x squared in Desmos. Let's see if it knows it. Let's try that out. I've never done this before. Let's see if Desmos is worth owning. And I got to get out of there, I guess. And I have to raise that power 2. And then this equals. And that'll be 4 parentheses x squared plus y squared. And sure enough, Desmos, look at that. Here's my point. The purple curve is the same as the black curve. They're the same curves. I'll toggle. Same curves, ladies and gentlemen. So appreciate the world of polar. The world of polar is to make your life easier, not harder. Anyway, you can mess with those cardioids. I want you guys to be careful, though. Okay, here's another note. We have other circles. You want to identify this. You might say, I have a circle where they'll say r equals a sine theta. That's a circle. And r equals a cosine theta. These are other kinds of circles here. Okay? So I'm going to go backtrack a little bit here for you. Because if they want us to graph, for example, they may say, you know, graph r equals maybe 4 sine theta, okay? I'm going to say to you, it's really good for you to know some of these equations so that you don't start to do extra work that you don't have to. There's an approach here that I want you guys to think about. And the approach you may already know. If I multiply both sides by r, we get r squared will be 4r sine theta. Okay, I just multiply both sides by r. So if I see that this is a circle, let's see what this gives us. On the left, from yesterday, x squared plus y squared. And then, because I'm really filling things in, I'm substituting. And r sine theta, remember, that's y. So that'll equal, you know, 4y. So we have x squared plus y squared is 4y. And then you say, Mr. Judge, how do I know that's a circle? Well, here's what you're going to do. You're going to complete the square, ladies and gentlemen. You see, when you actually do this on your final, you have to show your work. You don't go to Desmos and copy a curve and say, here you go. I mean, that's very high schoolish. If that's your strategy, that's a high school strategy, right? You trick the teacher, and the teacher doesn't care. Well, that's the teacher. Mr. Judge is not that teacher. He will say, no. You go, oh, that's mean. Well, okay. So complete the square, right? So you say complete the square with what? It's the y variable here because of the fact that there's your linear variable, right? This is y to the first power. So you always complete the square with that. That's the b value. So remember the complete the square procedure. It's b over 2 is my first step. And then I square that value. So in this case, -4 is my b value. Divide by 2 and I get -2. I'm going to use that. That's my first value. The second step is -2 squared, which will be +4. Remember, this is the complete the square concept. So I'm going to have some important numbers to use. Now, step 3, and I have this even outlined in my intermediate algebra course, because we complete the square there. So step 3, ladies and gentlemen, is where we use, here's how this works. We're going to use that 4. We're going to add the 4, and you're going to take away that 4, if you guys remember. So you add it, and you take it away. That's 0. So this is how we use this information. And then if you remember, these 3 terms, you factor. And the rest you actually add if you can add. Okay, what happens here? Here's what happens. If you remember with complete the square, you don't really actually add. You guys remember that? You don't really add, because if you factor, this is a perfect square trinomial. You always use the number found here in step 1. So you're not really factoring. I mean, you are factoring, but you didn't do the factoring procedure. You're using completing the square. And it looks like I could have kept my 4. Well, no, I don't keep my 4, but here we go. You get x squared plus y minus 2. Remember, this is squared now. -4 equals 0. And that's a square. This is how we complete the square to get this equation. This is really the equation of a circle by adding 4 to both sides. So you'll have, here's the end result of this. X squared plus y minus 2 squared equals 4. So this is how we identify circle centered at 0, 2. Radius is 2. So in other words, recall the general definition of the equation of a circle. X minus h squared. Y minus k squared is r squared. The center is hk. Radius is r. So, here's kind of an interesting thing here, just to let you guys know. When I have a Math 125 course, right? If I go back to the browser, you say, where are we at? Well, let's go over here to, this is Trig. We're going to go to Math 125. I have a bunch of worksheets and videos there. Graphing conic sections is kind of where we start talking about these circles here centered at the origin and complete the square. So I talk about this in my 125 intermediate algebra course, circles, ellipses, hyperbolas, and how to graph. And it's kind of interesting to me because of the fact that, when they tell students these days, when students are counseled these days, they're told things like, oh, skip, you can learn it all at the same time. It doesn't even matter. It all doesn't matter. Just skip. Start higher than where you're supposed to be. And if you fail, take it 3 or 4 times, whatever, right? Would that be maybe the least effective approach or efficient approach? Or would maybe starting in 125 be more effective, more efficient? Because sometimes it's like teaching students to fix a flat tire as they drive the car. This is sequential. Fix your flat tire, then drive. Try doing that. I'm willing to bet if you learn how to fix a flat tire separate from driving the car, do that first and then drive the car second, and everything will be well. If you say to people, learn it all at the same time, well, that's a difficult task, right? So this is covered in my course in 125 to show you. And, here's a lecture. If you said, I want to see, well, that's the worksheet. But here's kind of a video solution of that. So I have it for this class as well. And that was done 4 years ago. Anyway, ladies and gentlemen, I'm showing students how to graph circles and everything, as you guys can see there. Yeah. Anyway, just so you guys know, this is the world we're living in. Skip steps. Because it doesn't really matter. Or does it? Interesting. So, center of your circle. 0, 2. Radius is 2. So I would do the following. Now let's bring in. Does it let us? Should I copy? Let's bring this in. So if you said to me, how would I graph this one? I would complete the square. And let's see if it allows me to. Remember 0, what was that center of this circle here? 0, 2, I think. Yeah, 0, 2, radius 2. So what I would do, I would say, where if this was the XY coordinate system, let me 0, 2, where would that be? Here's my x-axis. Here's my y-axis. 0, 2 is down here. And this says radius is what, 2? I think a radius is 2. Okay. So that means I'm going to go through something like this. It's kind of not to scale in case you guys didn't know. But here's that center, 0, 2, radius 2. So here's kind of how you go about, this kind of question. And, that's again graphing the circles centered at the, it's not the origin anymore. And so you say this is r equals 4 sine theta, and a could be any value. And you say, what about this one? They give you r equals -3 cosine theta. You say, is that a circle? And I'll say yes. Right? Multiply both sides by r. Substitute. I'll put it in red this time. Substitute. Add your 3x to both sides. Now, if you're going to complete the square with a linear term here, the linear term is the x term. So put that next to the x. Okay, and then now you might say, okay, Mr. Judge, I see where you're going with this. You got to complete the square. With respect to this x variable. Now, you guys are in, this is your b value. So remember, you take b, you divide it by 2, so that's 3/2. We're going to use that. And then you say, I'm going to take that 3/2 and I will square it, which gives you 9/4. Okay. Step 3, the rewrite step. X squared plus 3x. Remember how you handle this. You're going to use this number first. You add it and you take it away. And that's what's going on here. You add it and take it away. That's really 0 when complete the square. But you now have plus y squared is 0. The first 3 terms you factor. So you get x, and you say, well, what number do I use? Because I don't really factor. You use the number found in step 1. This was completing the square, if you guys forgot, right? And don't forget you have minus 9/4 plus y squared equals 0. You're on your way. Add your 9/4 to both sides, ladies and gentlemen, and you end up with x plus 3/2 squared plus y squared is 9/4. This is the equation of a circle. All right, so we have to remember the equation of a circle. Let's see if you guys know. Let's ask you guys. Where is the center of this circle? And what is your radius value? Anybody remember what's the center of this circle? What's the radius on this?
To infinity.
Anybody remember? Remember how to do this? This is my H. This is my K. Oops, I have to change colors to get people to see that, right? So this is center is going to be negative 3/2. So you get negative 3/2, comma, 0. There is your center. And what's your radius now? You say the radius r squared is 9/4. You're going to use the square root formula. Also in 125, r plus or minus square root of 9/4. Now, that's the square root of 9, square root of 4, which is 3/2. So my radius is plus or minus 3/2. Or we say the radius is simply the positive answer. So, ladies and gentlemen, you're going back to those skill sets, negative 3/2, which is negative 1.5, and then the radius is the same, 1.5. So this is a form I would say to you, if you ever see this form, it's good to know, like the general equation, like equation of a circle, equation of a line. It's coming into play here. Here we go. Now let's get this out. Let's find this. So I can show you, ladies and gentlemen. Oh, come on. Why does it not want me to do that? Let's get what we need. It's all the way down here. Remember what we're doing. Center is at -3/2, 0. So that's -1.5. So I would do this. I would think about the Cartesian coordinate system over that polar. We're going to be smart about it. So we're going to plot -3/2, 0. That's to the right, like -1.5 here. Now, if my radius is 3/2 as well, so I'm going to go over here. And I'm going to have, I don't know, maybe something over here. I guess it's not to scale, ladies and gentlemen. It's really not to scale because I think 1 should be here. So let's kind of do it to scale here if we can. So if this is -1, let me change the color. So here's -1. It's still going to be a bit tricky. So let me do this. Let's draw the circle. Where the center of your circle here should be somewhere like this, -3/2. I know it kind of doesn't look to scale there. So it'll be -3/2, 0. And then here's our radius at 3/2. So ladies and gentlemen, there you go. X and Y coordinate. And there's the graph. So you have to go back to intermediate algebra. And I guess, intermediate algebra, like geometry, is a very good foundation for trigonometry. Who would have ever guessed? That used to be the prerequisites. But now they're just saying to everybody, hey, if you had something that looks like geometry in high school, then you should be able to be successful. Go ahead and try. So good luck, ladies and gentlemen. Doing this without prerequisites is a pretty tough thing to do. You know. And I should know because, you know, I had to try to do the same at one point. And I know it's like, wow. But here's how you graph circles, okay? So you're going to have to recall even complete the square. And if you said, I want to see more information on complete the square, go to the browser. And even with complete the square, if you go to 125, you know what I have? I got complete the square here. So I actually have an exercise in completing the square, but actually, you know, it's here, but I would say look at the conic sections because you're completing the square in relation to a conic. So that would be probably the best place to look to review some of those ideas on my 125 website if you needed to do that. Okay, but anyway, ladies and gentlemen, it's good to know the general equations so you know what to expect when you graph. So what I did today, if we go back originally here, I said to you guys, I wanted to start to kind of discuss these 4 things. And we did. We discussed these 4 things. So there's kind of, here's some of the graphs that, you know, typically I ask people, at least to start things off for you. Lines, circles, cardioids. And again, in a calculus setting, they definitely require that you know how to draw lines, circles, and cardioids. We're going to also see, you know, in our future, lemniscates and roses. So we're going to look at some lemniscates. We're going to look at some roses. And we're going to, you know, get some polar curves under our belt. So ladies and gentlemen, stay tuned. And again, if you want to see some more graphing on this, you know, let's go to our browser. Of course, you said, you know, Mr. Judge, what he did, and it's for its 241 students, under worksheets and videos, he has some more examples for graphing polar at this point. So you might want to see some of those. Is that graphing polar? What happened? I thought I hit graph. It's the last one.
That's the graph of r equals 2.
All right. There we go. Graph of r equals 2 cosine 2 theta. That's coming in our future. Okay, but I have another extra hour and 40 minutes just for you guys in case you wanted to see that. Okay? So, you might say, okay, Mr. Judge, at this point, what's in our homework 5? Well, we're going to add to homework 5 some graphing, and that's going to be on 8.2. So we're going to graph some of these here, and we'll get you started on some of these. Let's just say get you started on, 1 to 6 all. And then we're going to talk about, get you started on like 15 to 35 odd. We're not done with these. We got to do some more work, but you can certainly get started on it. Okay. And this is an 8.2 graphing polar equation. So, all right, ladies and gentlemen, I'm going to let you guys go. I'm going to have you guys put your name in the comment section. Of course, I have office hours coming up in about 5 minutes. So, we went over everything you need to do. And so I could get you guys some started at this time. Just print your name in the comment section and we should be good to go. So I want you guys to have a great day and take care and get to work on all the things that we've been talking about. All right. So take it easy. Stay safe.